So the object of this talk is development and research prioritization. Thanks all for coming. I want this session to be really interactive. Share your thoughts on what would be useful, what aspects of the discussed functionality might not be covered in a naive implementation, what kind of use cases you might see, and how the functionality library might serve them or not serve them. Help us find the right things to allocate our resources to, so that the most use can be made out of our resources. So plan for today is we're going to step through poll questions. There's a poll in behind this QR code. I was advertising it recently. The responses from the poll have given a little bit of indication on temperature for some of these things, but let's go ahead and kind of step through. I'm going to explain the feature briefly, get thoughts on how useful this would be from the audience, potentially discuss the design if that's if time permitting, and related functionality. And I also want to have a little bit of time at the end for kind of open-ended suggestions, if you have any. Just to get a sense, are there anything out there that are like how many people have asks for something related to a DP release in particular, or if you do, like raise your hand. Just so I have a, okay, cool. I'll probably ask you later.
If you didn't raise your hand.
Oh, I did, what?
It was the did or didn't.
Oh, if you do have some things to bring up later, then
Later, yes.
okay. Help to allocate time. So I think the obvious thing is in terms of our resources, like we want to put a lot of time into writing proofs and vetting proofs, and this will be like one of the biggest priorities in the upcoming year. I didn't put this in the poll because it seems like it's not like new functionality. It's just something that needs to happen. Yeah, go ahead.
There was talk, I think, there was talk at the last OpenDP meeting of having like functions in the library come with like PDF proofs and having a team of people like checking the proofs.
Yep.
Is that happening already? Like,
yeah. So if you look in the right places in the documentation, API level documentation, if there's a proof associated, then a link is automatically inserted, and you can click through that and get to the hosted PDF file. We like automatically rebuild those files every library release, and well, every night. So in terms of like the state of things, the proofs in the library right now are also behind a contrib flag. The way that we get that flag removed on both the code and the proof is through the review process. And the review board is set up now, and you have kind of a backlog of proofs for them to look at, and there's a lot more that we want to write. So that's the state.
There's like plenty of proofs that can be handled, so any kind of help is really appreciated.
There's a milestone on the GitHub repository covering open proofs that would be nice to have as a first pass.
Also, please say your names too.
Hi, I'm Abigail. I'm a PhD student and a contributor, I guess. How can we help? There's a lot of talk about the proof review board, but do we need to be on the proof review board? Can anyone sign up to the proof review board?
Good question.
Etc.
Right. So you definitely do not have to be on the review board to write proofs. kind of the model we're thinking is that anyone can come and open a pull request on the repository, just like you would for code, with just the .text file located next to the code you're proving. And since your contribution is in a pull request, that's a pretty good medium for pointing the review board at and saying, can provide feedback and on this proof. So essentially, if you send me a message on Slack and you're not sure, then I'll help guide you through it. Otherwise, if you open a PR, then I'll see it and direct people in your direction. Yeah.
I'm Alex. Finished my PhD at the University of Toronto. One thing I'm wondering is, in what ways do the proofs attached to the OpenDP API differ from like the kind of proof that we would see in a research paper on the corresponding algorithm? I guess I'm wondering, like, what is the level of granularity? Are we talking about like floating point issues and that kind of thing? Yeah, any information you have on that would be helpful.
So I just want to pull up one proof as an example. Sample discrete. We'll go with the discrete Gaussian. So here's some docs. You click through, find the proof. The general pattern we're following is you specify a Hoare triple, which is 3 items, precondition. So these are like the requirements on the inputs of your function, some pseudocode, the implementation itself, and a postcondition, or the thing you're proving. And then the proof, proving that the postcondition follows from the precondition and the code. So what kind of granularity? If you want your methods or the methods in the library to be accessible without opting into floating point, then it needs to consider floating point vulnerabilities. And so we're at a point in our library development where most things don't have floating point potential floating point vulnerabilities. So that the number of things you have to consider is much smaller in that case. But yeah, like if you want to drop that flag, to drop that opt-in on the user, then the proof should also consider
Right.
floating point.
So is that because most of the code requiring proofs is just building on primitives that are already in the library?
Yeah.
Yeah.
Yeah, and like the Gaussian mechanism and the Laplace mechanism that are in the library are like ostensibly acting like they're noising floats, but internally they're all discretized distributions. So it kind of avoids those problems. Yeah.
Okay, thanks.
Yeah.
Hi, I'm Moshe. I'm a PhD student at Hebrew U. We know that if we take it to real extreme, we can have like side channel attacks by like the time the computation takes and things like that. Do the proofs even go as deep as that, or is that something we live with for a while?
We live with that at the time being. There has been work on privately releasing the time that it takes to run the computation from Zachary Ratliff and Nicholas Berrios. There's a lot more side channels beyond that. So right now we're just saying as a blanket statement, we're not protecting against side channels. One path forward is we have another feature you opt into or opt out of, most likely, for different kinds of side channels. Okay, so I think an obvious direction beyond proofs is more functionality around data frames. Multiple use cases would benefit from this. Many individuals have asked for this kind of functionality. So supporting more statistics in this API, more data preprocessing transformations is, I think, a pretty standard, common development priority. But beyond that, contribution bounding, what's the general sense that it seems like there's quite a few asks for that as well. I was getting a request from someone that you might want to have the ability to specify multiple user IDs per record. I anticipate all this work happening also within Polars. But are there any thoughts from the audience on how this would be useful or not for your potential use cases? Yeah.
So I'm Nicholas, PhD student from ETH Zurich. So what I think in the current API is, at least if I understand it correctly, a bit dangerous is that you encode some properties about, for example, contribution bounds in like when you initialize the context, for example, but then there is no essentially enforcement check that is actually what is happening. And I think moving to something where you can say, okay, we have a privacy ID or a privacy unit specified in a column would actually make the use of the library also much safer in that regard.
I agree. It's more difficult to mess up an upper bound on user identifiers than an upper bound on user contributions. So it's one of these cases where I feel like once the functionality is present, then we adjust the documentation to make that the happy path, the suggested route for everything. So I agree. I don't anticipate this like us dropping existing functionality around this. I feel like at some point you render a node in your Polar's plan or your logical plan, your compute plan that does contribution bounding, and that's kind of represented as a transformation from this metric that measures distances in terms of user IDs into what we're currently using. So it'll be a mix. Thanks. I wanted to add a comment on Polars, something that I don't think I covered very well yesterday is we're not necessarily writing a Polars system, like a bespoke Polars system. We're writing a privacy calculus for a domain-specific language. Polars is nice for us because it gives us a DSL that has multiple front ends. You can build it from Python, from Rust, from R, from SQL, potentially. And it has a backend that can compute the plan. But it's like the scope of this work is not just like trying to make a nice feature around Polars. It's building a privacy calculus for a DSL. So like in that light, Polars has a SQL parser. So if people have SQL queries they want to run in a differentially private way, then we could, use the existing functionality in the library, in the Polars library, to make this compute plan and use all our existing code to analyze it. So it's one of the potential development directions here, part of the reason why it's appealing is because we can kind of make use of existing functionality. And so the kind of lift would be smaller. A complication on that, though, is there's like two kind of flavors of SQL. Well, many flavors of SQL, but put in two bins. You've got standard SQL and you've got SQL marked up with differentially private operations. And it would be nice in a general way if we can kind of introduce logic to the plan that makes the plan satisfy differential privacy, so that when people use the library, they don't need to insert node and insert noise here and specify contribution bounding there, and the library will figure out where to add those for you. But that doing that kind of work is involves more development time and resources. So, is there any sense of the utility and worth of kind of building this automatic rewriting stage, or do you think that would be better for future work?
Hi, I'm Albert. I'm at Google. I think this is probably very important. I just have the question being, like in that first bullet, like your input standard SQL, does that include like the epsilons? I'm not seeing.
Yeah,
the fact that
so you specify epsilon out in the context API.
Oh,
And
okay.
when it inserts nodes to the SQL query, it inserts nodes that make it satisfy that privacy guarantee.
Right, but I could imagine like you specify the unit, but then the query, like doesn't the query have to be like framed in a certain way to align with the unit? Like,
You're saying,
yeah. Oh, I'm not sure in full generality. Like, if you support arbitrary queries and arbitrary units, is it guaranteed that like they're gonna like line up, or is there something weird phenomenon might happen where like
yeah, so
edge case maybe?
like in the implementation of the library, we're kind of breaking it down into constructor functions that have like well-defined input domains and input metrics. And if it's doing the descent down the query and it finds that this next query stage does not align with our privacy unit,
Yeah.
with our domain, then the query is rejected. So there's potential for lots of rejections if your query is not somewhat standard and parsable by the logic in the library.
Okay, that sounds neat. Okay, thanks.
Yeah. I got one over here.
So I was just wondering, so Nicholas again from before. So using the SQL parser that's integrated into polars, is that not only going to be useful if you support like the entire or essentially almost the entire polars library already, because otherwise you're going to end up with primitives that you may not have support for in the library, and may need to think about how can I exchange these primitives with something that is semantically equivalent, and is that not going to raise some problems here?
Yeah, it could potentially raise problems. Like you would expect in the standard SQL, there's like min and max operations you might want to run. Currently, the node in the DSL that we're matching against is the clip node and not the min and the max nodes. So like there might be more nodes that are necessary to add to the for the library in order to parse it into something that we can verify stability guarantees for. I think that set is relatively small, the min and the max in particular. Beyond that, the thinking is like if you've got something like select distinct, then well, if we've implemented the distinct node in the general DSL parser, then you'd also get it for SQL, not just for Python and Rust APIs. So I think that we can get to that point with like 2 additional data preprocessing nodes registered in the library logic. Good comment.
No.
Joins. Want to talk about utility of these. I think kind of breaks down into 2 kinds of joins on a broad level. Joining with public data, I feel like this is relatively easy. Joining with private data would be a bigger lift because now you need a way of you got to introduce a new data domain that can span multiple tabular data frames and provide privacy unit information potentially for multiple data frames. Is there any sense of like in your use cases, if you have them, how this
Either now or in future, you or your organization might need anything. It'll actually help us drive our roadmap forward. So yeah.
a lot of these items are on the list because we've had asks from use cases. So it's not like we're completely running in the dark and just trying to find something to do.
There's a lot to do, but
a
we
lot
want to
to do
prioritize it.
that has been asked and would help move along potential deployments. But it gives a little bit. This is giving like a little venue for people to potentially provide some feedback on the design and the thinking of the library. A hard question to answer. It's very general. Distributed compute. So we've put a lot of resources and effort into building this integration with Polars. Polars does not support distributed compute. So how does it square away with like big data sets? Out of the box, Polars has this method for streaming data through a single computer. So you can get the data sets much bigger than you would have otherwise. Since the data representation is in Apache Arrow, then that helps as well. But at a certain point, you want something that can span multiple computers. Thinking around this is that this compute plan I'm talking about, this DSL, can already be extracted to JSON. So someone else can kind of use this stub to write combinators. Combinators are things that take a measurement, output a new measurement, that kind of replace the function on that to run the computation on different backends. So that kind of the stub is there for that work to be done, but I don't anticipate us having the resources, or at least me and Chuck having the resources to build that out in the next year. Hopefully someone else will do it. Okay, so we also have an R package. There are some drawbacks to the R package. The R package is providing framework APIs, not context APIs. There's no way to write your own R code from and integrate it into the package from R. That's kind of a nice functionality for Python and Rust, is that you can kind of just build your own transformations, measurements. Not an option for R. And while Polars does provide R bindings, we don't do the work to integrate with them in the R package. So I mean, maybe get a sense of the temperature in the room around working in R. How many people work in R for their DP analyses? Or is it mainly Python or some other language?
Raise your hands if you do R. Oh, okay.
Wow, interesting. Are there any other languages beside Python that you find useful for your work? It's really concentrated to Python. Interesting.
Everybody loves Python.
Yeah.
Okay. I think it's always speak at the mic.
Yeah, I think it's just the audience who came to this room.
Mhm.
It's kind of skewed towards as computer scientists and programmers. Like I think from what I understand, R is more popular amongst natural sciences and possibly social sciences, maybe. So it's just like who came to the room.
Yeah, I think there is a fair sampling bias here.
Mm.
But there's also been a lot of asks for functionality from R,
Sure, yeah.
also from use case partners. So at least in terms of like prioritizing development, the use cases that have asked for R functionality are met with existing framework level APIs. So barring more things that would come available, it feels like putting off these kinds of development on the R package is ideal.
Well, at one point, there's something in the chat. Is that?
Oh yeah. Yes, statisticians and medical sciences would use R. Raphael.
You should have come.
So we got a vote. Very good vote. I think that I do feel like the amount of work necessary to bring the context API to R would be low, and it would provide a high amount of utility. It's a lot easier to work with the context APIs than it is to work with the framework level APIs. And since the context APIs are basically just a layer of pure R code on top of existing R code, then a lot of the complications around like cross-language communication and the code itself being privacy critical are reduced. So it helps make that more approachable.
Oh, can I answer your question about generally who the use cases, like what type of people are making the asks, like who is currently has use cases that are making requests?
Yeah. So one use case was from FSO, Federal Statistical Office. I think we'll have probably another chat comment, maybe from Raphael. There's also been a number of individuals that have asked for this, and when there was a bug in the R package, then I pretty quickly got requests for help. So it tells me that there's some usage there.
It's the best way to do a survey. No.
Yeah. Surveys are difficult because response rates are very low.
Then you know how many users you have. No, I don't think it justifies a microphone. But like, honestly,
I guess I also meant more generally, like for all of the feature requests. Like, are they mostly coming from like developers, statisticians, or like smaller industry partners?
Agreeing with Raphael, statisticians. I think that there's, I also agree about medical sciences, and I think that would be a place where you could do a lot of, for good work. So it would kind of help with their mission. Raphael says we're using public health office. We're helping public health office using DP in the user. All right, clipping bounds estimation. I've had a little bit of a skepticism about algorithms around clipping bounds estimation. General motivation here is that providing ways for individuals to estimate free parameters would kind of help the usability of the library. Clipping bounds is one case of that. Although I've noticed in a lot of cases, you get better utility by making really rough estimates of clipping bounds. And in most cases, there are some prior information that you can use to estimate those clipping bounds. Nevertheless, I want to take a chance to pull for any suggestions on algorithms that are used to estimate clipping bounds. There's a couple of them on here. Compute a histogram, post-process it, as Damien Defont suggested in his Unbounded SQL contribution paper. There's a method from Anonym where you use above threshold mechanism to repeatedly query for clipping bounds using stability histograms in a similar way as the first looking for bins that exist in the stability histogram. Anyone familiar with other methods that would be good to use here or recommendations?
I mean, these methods can be really application dependent. So hopefully we'll be able to get something or come up with something which is like more versatile. So any suggestions?
Yeah.
So I don't know if it falls under the versatile definition, but like just the classical Gaussian or sub-Gaussian mean estimation basically go also through a sort of estimating the clipping bound by estimating the variance. I don't know if you would consider it as versatile enough to fall in this category, but this is probably like a relatively basic building block that we wouldn't use.
One complication of estimating the variance is then you need clipping bounds for the variance. For like the
But there's like a known algorithm for specifically for Gaussian or sub-Gaussian, which like it's effective. It's a histogram over the variance, standard deviation. Once you have that, you know the bins for the mean, and then it's 2018 paper. Like I know when people work on mean estimation in Gaussians, this is like the first step, and then you need to deal with like multidimensional or whatever.
One that goes to like one-dimensional case.
Yes, that's it. I'm not sure it can be. I mean, it's versatile because like half the world is Gaussian, or we believe it's Gaussian. But on the other hand, it's one-dimensional. It's
heavy tail data.
Okay, I don't know. The world of statisticians, the world of computer scientists, whatever. It's not for me to say.
Sorry, apologize. Do you have some? Okay.
Thanks. Notes. Oh, so we all have a
Maybe
comment.
I mean, refining the question. I mean, they're like specifically the 2018 paper. I would not recommend to implement it. Kind of is a theory paper that is kind of quite. I mean, I'm at least partly to blame on that. That is kind of free with constant factors in the epsilon, and spend a little epsilon here, spend a little epsilon there, many steps. The question is there I mean, there's been a lot of developments, including going to more than, multi-dimensional since then. Is there something that kind of go to like really practical method that we should consider incorporating?
Maybe that can be an open question as well.
So, Christian, I think from a TCS perspective, it would be useful also to understand, what kind of situations do people want into in practice when they're trying to choose their clipping bounds? Because you can
yeah, in TCS, one technique is also to use a noisy binary search to sort of figure out, okay, what kind of clipping bounds are you working on, and it falls into a little bit the same technique as the above threshold. You can also, for certain kinds of data, you can also use the exponential mechanism to choose a clipping threshold. There you need some assumptions on how the data looks like. If everything is clumped very closely together, you can run into trouble. I don't know if that's. I think that would work pretty well in practice. Yeah.
Like another method, I mean, maybe this is what you're talking about, but like just estimating the 0.05 and 0.95 quantiles. And
Yeah, exactly. So and there are several ways of doing that, right? So one is exponential mechanism. So quantile estimation using sort of inverse sensitivity is.
I guess that's a setting where inverse sensitivity is actually tractable. So.
Yeah, so from theory perspective, it would be helpful to know, okay, what kind of challenges do people actually run into in practice? Because that can help us guide, okay, what kind of algorithms do we actually want to use?
Right, it's a little too broadly scoped. I don't have a good answer to that, so.
I don't think anyone has.
Algorithmic primitives. So we have a fair number of mechanisms in the library already. We want to be able to support both like individuals who are implementing a broader DP algorithm. They can ideally just plug in the specific mechanism and use that. But also, if you want to integrate with a bigger system, as mentioned in kind of Christina Ilvento's comments, like you might want to only insert DP at a specific spot in an existing pipeline. So having standalone algorithmic primitives supports that. We don't have an above threshold mechanism in the library. Like all these things we can do, and we have variations of implementations for above threshold is in a PR. We'd like to move that along. We have a report noisy max mechanism for Gumball, but not currently exponential. Just some work Tutor's been doing to move that along. But like what kinds of algorithms would be useful for your use cases when you're building up your algorithms?
Sorry, this is a question. So these are functions that you can kind of pull out of the library and use within your own pipeline without kind of building the whole thing.
Like
inside
you call make
inside
Laplace and it makes a Laplace mechanism, or make above thresholds and it makes a exactly. And the list is not exclusive to these, of course.
Yeah, I'll just make a comment that I think these are super helpful for as coming from big tech. I think this is kind of where we could most get the most use out of something like OpenDP is pulling specific functions that are needed and putting them in separate pipelines.
So given that Polars you said that it has streaming, like ability to stream data, is there any interest in having more like low memory algorithms for different things?
Yeah, I think so. My answer is always yes. But we got to temper by where we allocate our resources. If there is outside contributions for a specific aspect of the library, then it really it motivates me to help move those along because it's not one person working on it, it's multiple. So you can kind of help amplify development in an area by doing work in that area. I find that there hasn't been any contributions at this point around like continual observation, around streaming. 5 minutes. So, but of course, I'd love to support it and have designs for it. Okay, combinators. Usage of, say, adding odometers and privacy filters. Odometers being ways of accounting for the budget without an upper limit, and with dynamically set privacy parameters for each query. Privacy filters are the same, but they have an upper bound. It feels like having these in the library would help us integrate with other libraries, like, for example, Opacus, where the privacy accounting is done via an odometer. So, like, if we want to, work with other libraries that reason about privacy in this way, then it'd be great to have that. It's also kind of a nice utility, sorry, not utility, a nice usability bump. Currently in the context API, you need to kind of specify all your privacy parameters up front, and that makes things more difficult to use. But like, there's a lot of other, projects out here you could work on. Private selection from private candidates. Shlomi Hod has been doing some great work in that area. It feels like a lot of potential use cases would need, would benefit from hierarchical queries. This is a setting where you have, you're answering the same query at different levels of aggregation, and using all of your answers for each level of aggregation to reduce the variance of estimates at each level. You think of it like a in-census use case where you have a geographic spline and grouping by block, grouping by zip. I don't remember the exact details, but each of those marginal queries are brought together. Any suggestions about algorithms or allocation in the space?
So one suggestion and one general question. A suggestion is like the direction of the accuracy first type of algorithms, which once the odometers and filters were invented, they became more useful because now, especially if it's someone from the industry, so they really sometimes work in the accuracy first framework. So maybe it's relevant. And a question, just because I was never involved in doing it, I'm trying to understand how is it seems to me like above threshold will be like a 10th or even less than a 10th of the work required to do these kind of things. So just like, what is if you can show, what is the dynamic that led to the fact that like you're considering getting such a small basic component and such a large component, and they're sort of competing? Like, how does it happen?
It's interesting. Work on odometers and privacy filters has been ongoing for years. At this point, I have a working implementation of them that's cross-language, and the question is allocating resources to get them over the finish line. It seems like that's kind of one of those projects where it's been a very very painful process to get it right. So just because it's working and implemented doesn't mean that it's something that we can release at this point. They're competing in that sense, in that they're both at a stage where they may take a similar amount of resources to bring over. Yeah. Yeah, so I didn't expect us to get through every slide I made. So I definitely have more slides out here, and it's been, how long do we have?
We were over time. So.
Okay, so I should wrap things here. There was a lot of really great comments in the session. I was honestly kind of surprised and happy to get so many great feedback from people.
If you're able to fill out the forms, the one on with the QR code over there, that'll be excellent. It also has like a text box in the end for open, like more suggestions and everything. So we'll really appreciate our input.
Please elaborate.